All right, so here is the second example that I'd like to go through with you today. This one is about Patrick trying to kick a rugby ball over the crossbar of a goal. The feet of the goalposts are 13 meters away from the point where he kicks the ball. The vertical height of the ball is approximately modeled by this function. And then it tells us that that x is the horizontal distance in meters, and it wants us to find some things. All right, so let's go for it. The first thing it wants us to find is the maximum height of the rugby ball. Now remember, this is what's happening. I've got the ball here. He's going to go kick it, and then here's the rugby posts, which are 13 meters away, and he's going to kick it up and hopefully over the posts, and we'll see. We're not worried about any angles or anything here, just doesn't make it over the post. So first we're going to find the maximum height. All right, so the maximum height is, of course, the vertex, right? When I find the maximum height, it will be the vertex of that curve. Now, we're going to go ahead and do this the same way that we did the last one, right? We've got y, or f of x, is equal to negative 0.1 x squared plus 1.5 x. And so the first thing we're going to do, very similar to the last one, is we're going to go ahead and find the x-intercepts, okay? So to get the x-intercepts, we're going to make y equal to 0. And now that y is equal to 0, we can say 0 equals negative 0.1 x squared plus 1.5 x, which then should allow us to solve for x being 0 and x being 15. All right, so now that I have those two x-intercepts, I should be able to find the position at which I get to the maximum height, okay? So that would be the middle of these two, right? That's what we did in the last one. We said, okay, well, here's my symmetric curve. Where is the maximum happening? The maximum should happen, if this is 0 and 15, the maximum should happen somewhere in between, which may or may not be where my goal is here. All right, that's not quite what I wanted to do, but that's all right. So we'll go ahead and we'll find the middle of those two, which would be 7.5 meters. So x equals 7.5 is the center. That's this right here. And so now I can find the y value at that point by taking that 7.5 and putting it back into the original function, which then will give me the maximum y value, which is 5.63 meters. Awesome. Okay, the next question says, find the coordinates of the y-intercept. Explain what this tells you about the height from which Patrick kicks the ball. Okay, well, we found the x-intercept right here. To get the y-intercept, you actually already have it, but in case you didn't recognize that, the y-intercept happens when x equals 0. So I put 0 into the original function, and I get y equals negative 0.1 times 0 squared plus 1.5 times 0, and I get y equals 0. Okay, so that's my y-intercept. My y-intercept is 0. So what that means is that from the point that he initially kicks the ball has a height, because y is the height, of 0. And so that's all it means. All right, so that's easy enough. We found the coordinates of the y-intercept. X was 0, y was 0, and this tells us that the height was 0 when he kicked the ball. All right, now the last question says, given that the crossbar is 2.5 meters above the ground, determine whether the ball passes over the crossbar. Justify your answer. Okay, so we're now finding that the crossbar is 2.5 meters above the ground. We also knew that that was 13 meters away. So can we figure out whether the ball goes over the top? Why, yes, we can. We can go back to the original equation, but this time we're going to put in negative 0.1, and we're going to put in the distance of 13, like that. Okay? When we put those numbers in, we find out that y at that point equals 2.6. You can put that into your calculator. Please do it. Make sure that I'm right. I make some mistakes from time to time. Pretty sure I didn't make a mistake on this one, but you never know. So beep, 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 beep. We got y equals 2.6 meters. So at 13, that means that the ball is 2.6 meters in the air. Is that higher than the required 2.5? The answer is yes. And so it will go over the goalpost as long as he hits it in a straight line. All right, so that's it for today. Just wanted to make sure that you had a couple of examples of this quadratic stuff. You've got the skills, so now let's go ahead and use them to apply, which is what this course is all about. So thanks for watching, and good luck.